Alright, today we're going to be talking about calculating volume of cylinders and prisms. So you've done this before, so a lot of this might be review. We're going to take what you know since middle school and take it up a notch. So the volume of a solid is basically how much space that this shape takes up. So if you think about your tissue box, how much space does that take up, or your textbook, or a ream of paper. So, talking about a ream of paper, you have a bunch of sheets of paper that when you stack on top of each other, you get your stack of it. You can think about your single sheet as a two-dimensional shape, and then as you add those two-dimensional shapes up, that's when you get your three-dimensional shape of the stack of paper made up from those single pieces of paper. So the formula for the volume of a prism is the area of the base, noted as big B, times the height of your prism, where big B is the area of the base. And remember, the base can be any shape. It can be a rectangle, it can be a hexagon, it can be a triangle. So whatever the area of that base is, you multiply it by h, which is your height, and that is your volume. A lot of times I've seen people say, oh, volume is your length times width times height. And just remember that this will only work in a rectangular prism. So be very careful about this formula here. We will use it, but that will only work for rectangular prisms. Now the volume of a cylinder is the same idea, big B for the base times the height. However, since a cylinder always has a base that is a circle, instead of writing big B for your base, you can just write the formula for area of a circle, which is pi times r squared. So we can replace base with pi r squared, and that will just make life a lot easier for us to work with. And of course, your times h will just be hanging on the outside. So B is the area of the base. H is your height. And R is the radius. And again, the volume formula that I will be using is pi times r squared times h, because that doesn't force me to remember anything differently. Alright, let's look at some examples of calculating the volume. So we have the first one. This is a right triangular prism. So here's our bases. These two triangles. So we need to find the area of that base. So the base is equal to 1/2 times base times height. Now remember, in a right triangle, it doesn't matter which side you make your base or height, because you're going to be multiplying them anyway. This will be 1/2 times 3 times 1. And if we type that in the calculator, we get 1.5. So the area of this base here is 1.5. My height is this dimension right here. The length that connects the two bases, that is our height. So then our height is 2, and that will make our volume big B times h. So that equals 1.5 times 2 which is 3 feet cubed, or 3 cubic feet. That is how we talk about volume. Our units are cubed. Alright, now for the second one, find the exact volume of the right cylinder. Well, the exact volume means we need to have pi in our answer. So the volume equals pi r squared times h, or the height. Your height is 6. Your radius is 5. So we'll substitute those in. Volume equals pi times 5 squared times 6. Volume equals 5 squared is 25. 25 times 6 is 150. And again, because it says the exact volume, I'm going to leave pi alone. So my volume is 150 pi meters cubed, or cubic meters. So just remember to read exactly what the question is asking. If it said round up here, then I would have typed this into the calculator to get a decimal approximation. Alright, on to the next page. Now it says the volume of the right cylinder shown is 1,253 cubic centimeters. Find the value of x to the nearest hundredth. So volume equals pi r squared times h. We know h is 10, and we know the volume is 1,253. So we can substitute those in order to find out what the radius is. So 1,253 equals pi times r squared times 10. But we want to get r by itself, so I'm going to divide both sides by pi times 10, or 10 pi. That's probably a better way to write it, so let's do that. Because that will cancel these. And then the left side is going to equal 39.79 equals r squared. And then when we square root both sides, we're going to get 6 point, let me double check, 39.7, we get 6.31. So 6.31 centimeters is equal to r. Okay, so hopefully these 3 examples weren't too much of a stretch. Maybe it was, okay, now that I've seen it again, I remember from middle school kind of what we're talking about. Just remember to know where your bases are for your prisms. Alright, so we're going to take the information from above with the volume formulas and apply it to something called oblique solids. Now, oblique solids, the best way to kind of think about that is a slanted shape, or a slanted solid. You know, the cylinder up here, this is a right cylinder, like your pop can, your water bottle, your toilet paper roll. Those are all right cylinders. Here, an oblique cylinder would be something like the Leaning Tower of Pisa. You know, this is slanted, it's leaning. This would be an example of an oblique solid. To calculate the volume of something like this, or any oblique solid, we're going to use something called Cavaliere's principle. And what that states is that if you have multiple shapes that have the same cross-sectional area, meaning the area of these cross-sections that I'm highlighting are the same, and the height is also the same, then the volumes are the same. So these three shapes here, even though they look completely different, one of them is round while the others are more rectangular, those all have the same volume because they have the same height and the cross-sectional area is the same for all of these. So the area of each of these bases are the same. So another way of seeing that is to look at the stack of pennies down here. Obviously they don't look the same at all, but there's the same amount of pennies in each stack. This is one cylinder. This is just a mess. I don't even know what shape you would call this. But because they have the same amount of pennies, you would say that the volumes are the same. That the area of each base is just one of these pennies. And the height is the same. So you would say the volumes are the same. So if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. At every level of our stack of pennies, the cross-sectional area is just one penny. And there's the same amount of pennies in each pile, so those two piles have the same volume, even though they look completely different. Alright, so let's see how we can use that on the next page. We have this cylinder here. This is an oblique one because it's slanted. We're going to find the exact volume, so we want to leave pi in our answer. This is the height of our cylinder. Kind of like how we used to have some triangles where the height of the triangle was outside it when we were calculating area. Same idea here, where the height of this cylinder is actually outside of that cylinder. So our height is 8 and our radius is 5. So the volume equals pi r squared times the height. So we can plug that in. Volume equals pi times 5 squared times 8. Alright, 5 squared is 25 times 8 is 200. So the volume equals 200 pi. And our units are cubic inches. And since it says exact, we are going to leave that alone. Alright, example number 5 is where things get a bit complicated. First, we are given the diameter, not the radius. So the radius is half the diameter, or 6. Now the height, we don't have the height. We have this slant length here. We have this as 18. Well, if we look at this, we have, oh my gosh, it's a right triangle. Now, you could use special right triangles if you remember those, but since we have our calculators, you can also use SOHCAHTOA. We are trying to figure out this side right here, the height, and we are given 60 degrees. We know the hypotenuse is 18, and this side, that is x, is opposite from our 60 degrees. That means it's going to be sine of 60 degrees equals the opposite, which we don't know, over 18. So we can replace opposite with x. That will make things a little bit easier. Multiply both sides by 18. And then when I type into my calculator 18 times the sine of 60, I get 15.59. These 18s cancel. So that is our height. Height equals 15.59. So now we can use our volume formula. Volume equals pi times r squared times the height, and plug everything in. Our radius is 6, and our height was 15.59. So I would type all this into the calculator, just like this, just like as you see it. I wouldn't simplify anything. Just type that in, and the volume is going to equal 1,763.19 cubic millimeters. Okay, so what I want you to do is you have two problems on this page and two on this page. What I want you to do is I want you to try these, all four of them, and once you've completed them, unpause the video and see if you get the same answers that I did. So go ahead and pause the video. Alright, let's see what you got. So hopefully letter A was pretty simple. Multiplied 11 times 4 to get the area of the base, and then by 5. You probably just typed it on the calculator like this, which is fine, to get 220 cubic meters. Now, letter B, it said exact volume. So once I plugged everything into the formula, I just left pi in my answer. So realistically, what I did in my calculator is I just typed in this part, and that gave me 324, and then I just put the pi at the end of it. Now, the next page, this one, letter C, was probably the most complicated one. Your base was this yellow triangle down here, and it's a right triangle, so then you would just use your area of a triangle formula from right here. It's 1/2 times the base times the height of that triangle. So that's why I did 1/2 times 9 times 5 to get 22.5. Then I can plug that in for the big base, and then your height was 8, and then when I type that into the calculator, I got 180 cubic meters. And then for letter D, it's almost exactly like the one that we did earlier, example number 3, but what you had to do is at the very end, once we got the radius, you had to multiply that times 2, because x up here is the diameter of the circle. The formula for volume gives us the radius. So once we find that radius, we need to multiply by 2 in order to get the diameter. Alright, so hopefully this was not too difficult, and it was a good refresher. And then in class we're going to work on this and take it up a notch. So thanks for watching. Make sure you like the video and subscribe. See ya.